Alright, this is problem number 2 of extra credit for exam 3, and it is a problem from the book, and it reads as follows. Write the equilibrium constant expression Kc and Kp if applicable for each of the following heterogeneous systems, and then it gives us the following systems: A, B, and C. So first we're going to do A, which I already wrote down, and A is ammonium selenide yields ammonia and hydrogen selenide. Alright, now we know that the equilibrium constant expression is equal to the concentration of the products over the concentration of the reactants, and we do not include things such as solids and liquids because the change in their concentration doesn't really affect the equilibrium constant. So all we have to do now is plug in the values or the compounds that they give us, sorry. So it's going to be the concentration of the products, so ammonia squared because of those of the two moles we have here, and then the concentration of hydrogen selenide because first they're both gases, so we can include them, they're not like a solid or a liquid, and then our reactants would be on the bottom, the concentration of reactants would be on the bottom. However, the ammonium selenide is a solid, as we can see here, so we don't have to include it. So for A, our equilibrium constant expression would be this right here. And then for Kp, the equilibrium constant in relationship to pressure. For it, of course, we're not going to include our solid because Kp is just related to the gases, and we can write it as follows: P for pressure, and then the 2 for the square, and then the ammonia, or the, yeah, and then P for pressure again, and then the hydrogen selenide. And these are our two equations for ammonium selenide yields ammonia and hydrogen selenide. Alright, now we're going to find the same equilibrium constant for the heterogeneous system B. However, as we can see, even before starting, none of our products or reactants are gases, so we're not going to include Kp here. We're not going to do the equilibrium constant in relationship to the pressure because that's only, again, related to gases. So for the equilibrium constant, again, it's the products over the reactants, and our products are the concentration of products over the concentration or reactants. It's going to be silver ion times the chlorine ion, and then our silver chloride, it's a solid, so we don't have to include it, and this would be for B. Now C. For C, first we're going to start with the equilibrium constant for the concentration, and we're going to do again our products over our reactants, but then we have to remember one more time that we can't put liquids or solids in our expression. So therefore, for our products, we cannot put the phosphorus trichloride, I'm sorry, and therefore we have to put a 1 because we can't put anything there. And then for our reactants, we cannot put phosphorus, but we can put chlorine. So we're just going to put chlorine there on the bottom. And then again, because of the moles that they give us there, 6 moles for chlorine, we have to put that to the 6th power. And that would be our concentration, our equilibrium constant expression for concentration, then our equilibrium constant expression in relationship to pressure, would be the same thing basically. However, instead of it being over the concentration of chlorine like we did over here, it's going to be over the pressure of the chlorine, just like that. And these are our equilibrium constant expressions for C. And then these are our total answers for A, B, and C. Thank you.